My name is Jeffrey Edmiston, and today I'll be presenting the key aspects of my final year engineering thesis project. The name of my project is the application of replacing a percentage of coarse aggregate with glass in concrete. During this planning stage, extensive research on a series of academic-related documents of similar nature to this study will be undertaken in order to establish common factors which may indicate an approximation of the expected testing results. The implementation stage of this study was also designed around this research and looks to utilise the common factors in terms of workability, water-cement ratio, grade of concrete, and mixed design ranges to ensure accuracy when comparing the tested results with the expected literature results. This study will aim to establish whether waste glass can effectively be used as a replacement for coarse aggregate, and if so, the optimum percentage replacement of glass for coarse aggregate in order to maximise the strength of concrete. From previous research, waste glass has been proven to be an effective additive to concrete as the strength increases if substituted for a percentage of coarse aggregate. For centuries, glass has been serving as a universal packaging container. With time, the increasing use of glass products is resulting in significant amounts of wasted glass. Reusing, recycling, and waste reduction are very important elements in a framework of waste management. However, not all used glass can be recycled into new glass due to impurities, cost, or mixed colours. It is necessary to establish new options to utilise recycled waste glass. One option is to use waste glass as construction materials. The demand for concrete is expected to grow approximately 18 billion tonnes per year by 2050. Consequently, the concrete industry is going to use a considerable amount of natural resources to produce cement and concrete. For this reason, research works have been conducted on alternative building materials, and significant space is covered by potential use of waste or recycled materials in concrete. Previous studies have shown that waste glass can effectively be used as a coarse aggregate replacement. The aim of this study will be to discover the optimum percentage replacement of glass for coarse aggregate in order to maximise the strength. In order to study the effect of waste glass as a partial replacement of coarse aggregate on the strength of concrete, results from previous studies conducted in the past will be used in order to establish an estimate. This number will then be plus and minus by 2.5% in order to establish the percentage replacements that will be used for this study. In doing this method, we're giving the study best possible chance of achieving the project aim. Other deliverables that this study may discover is the workability and durability of the concrete, as well as other fresh and hardened properties whilst using glass as a partial replacement of coarse aggregate. The graph shown is a recent study of an almost identical experiment. As you can see, there is a slight increase in compressive strength between 0 and 20%. It can also be seen that a specific replacement percentage of 10% of coarse 10mm aggregate with coarse glass was marked as the highest strength reading of the experiment. This figure will be used over the course of this study in order to establish a more accurate number, as previous studies, including the one shown, have only increased replacement percentages in 10% increments. Therefore, for this study, percentage replacements of 7.5%, 10%, and 12.5% will be used in order to establish a much more accurate figure in the optimum percentage. With more than 10 billion tonnes of concrete produced annually, concrete is considered to be the most important building material. It has been predicted that the world's population will increase by 6.9 billion people by the present day by the year 2050 and 11 billion by the end of the century, which will result in a considerable increase in the demand for water, energy, food, river sources, common goods, and services. Recycled glass contains a unique inert material which can be recycled many times without changing the chemical properties. It is good in compression and it has good insulation properties. Most waste glass have been dumped into landfill sites. The landfilling of waste glasses is undesirable because they are not biodegradable, which makes them environmentally less friendly. Therefore, the significance of this study is quite large. By discovering an optimum percentage that we are able to replace aggregate with a non-biodegradable waste product that is in fact increasing the strength of the structure. Thank you for listening to my presentation. I hope you're as enthusiastic as I am about discovering the optimum percentage replacement of glass for coarse aggregate in order to maximise the strength of a concrete structure. The idea of removing 700 million tonnes of non-biodegradable waste material from landfill, which in turn creates stronger structures worldwide, must excite audiences around the world.